Python machine learning. So for this video lecture, we have polynomial regression for our topic. Again, my source for this topic is W3 Schools. Now, polynomial regression. If your data points clearly will not fit a linear regression, so that means it's a straight line through all data points, it might be ideal for polynomial regression. Polynomial regression, like linear regression, uses the relationship between the variables x and y to find the best way to draw a line through the data points. So just like what is shown here. So we have here the data points, and maybe this is the line that can be drawn through the data points. Now, how does this work? Python has methods for finding a relationship between data points and to draw a line of polynomial regression. We will show you how to use these methods instead of going through the mathematical formula ones. So in the example below, so in this example, we have registered 18 cars as they were passing a certain toll booth. We have registered the car's speed and the time of day, so hours, the passing occurred. The x-axis represents the hours of the day, and the y-axis represents the speed. So the y represents the speed, and the x represents the hours. So in this example here, we use matplotlib library and the pyplot to plot the scatter diagram. So we have x, again x here represents the hours, so from 12 midnight to 12 midnight, maybe just before 12 midnight, and then here are the speed. So plt.scatter x, y, so we plot x and y and then show. So this will be the output of the points we place here. Now we import numpy and matplotlib, then draw the line of polynomials. So this time around we're going to draw this line. So the same, we have numpy and matplotlib pyplot as plt. So we have here again the hours, and we have here the speed. So my model was numpy poly 1d and numpy poly fit x. So these are the values of x, y, and 3 here is the degree. That will be explained later. So and then my line, this will represent maybe some sort of the x-axis here. It's numpy line space, so starting from 1 up to 22 and with 100 points. So we'll be using some sort of 100 points to plot the polynomial. So plt.scatter xy, so this is the scatter diagram, and then plt plot my line, that's the x-axis, so and my model my line, so that's now the y-axis, and then plt.show, so we'll show the diagram. So this will be explained again in the next slides. And how does it work? So first is we import the modules you need. So we have numpy and matplotlib pyplot as plt. So we'll be using only this function inside the matplotlib, and we have renamed pyplot to plt. Now create the arrays that represents the value of the x and the y-axis. So x again represents the hours, and y represents the speed. NumPy has a method that lets us make a polynomial model. So we'll be creating a polynomial model out of this one. So my model equals numpy.polynomial, so 1d, numpy.polyfit x, y, and then 3. Again, 3 here represents the degree. So if, let's say for example, this is an equation, we have x cubed, then that means 3 is the highest degree in our equation. Then specify how the line will display. We start in position 1 and end at position 22, and then we use some sort of 100 lines or 100 points divided into these lines. Then we draw this original scatter plot. This will draw the scatter plot, and then draw the polynomial regression. So we have the x, my line, and my model, my line will be the y value. And then display the diagram, the two diagrams here. So plt.show. It is important to know how well the relationship between the values of the x and y axis is. If there are no relationship, the polynomial regression cannot be used to predict anything. The relationship is measured with a value called the r squared. The r squared value ranges from 0 to 1, where 0 means no relationship and 1 means 100% related. Python and the sklearn module will compute this value for you. All you have to do is feed it with the x and y arrays. So how well does my data fit in a polynomial regression? So let's try to test if our data fits polynomial regression. So we import numpy and from sklearn.metrics import r2 score. So that's r squared score. So my model equals numpy.polyid numpy polyfit, so xy3. So this is our model, and then print r2 score, so y and my model x. Okay, so take note, we have y first and then the x value. So this is how we measure the relationship with the r squared, and the result for this example is 0.9432150. So the result of 0.94 shows that there is a very good relationship, and we can use polynomial regression in future predictions. So take note that if you're near to 1, then that means it's a good fit. So there's a relationship. But if it is near 0, then that means there's not a good relationship, and maybe we could not use polynomial regression. So let's now try to predict future values. So since we know it is okay, our data is good for polynomial regression, so we can now use this to predict values. So now we can use the information we have gathered to predict future values. Example, let's try to predict the speed of a car that passes the toll booth at around 17 p.m. So that's around what? 5 p.m. So to do so, we need to say my model array from the example above. So my model, we have this one. So predict the speed of a car passing at 17:15. So import numpy from sklearn.metrics import r2 score, and then we have here x. So I don't think we need this one, but it's just okay. So x equals the value y. So my model is equal to numpy polyid numpy.polyfit x y3. And then my model 17. So that's the value of x. Speed. So print speed 88.87. So that means this is most probably the speed of the car if this is the time. So the example predicted speed of 88.87, which we also could read from the diagram. So this is 17, and then we look for the y value, which is 88 something around 90 or before 90. So that's 88.87. Okay, so how will we know if it is a bad fit? So let's create an example where polynomial regression would not be the best method to predict future values. So here we have the value of x and y axis should result in a very bad fit for polynomial regression. So we have x and y. So we tried this one, my model, numpy, that line space, 2.95, PLT scatter. So scatter, PLT plot line, my model, you notice the line here, and PLT show. So you notice that how far the dots are, or the data are from our line. So and the r squared value, so if you compute for the r squared value, so we have r squared, so just like a while ago, we have the x and y, we get the model, using these functions, and then we use r2 squared, so y and x, my model, and then we have here 0.0099. So it is very far from 1, and that means it's a bad fit. That means we cannot use polynomial regression to predict the values. And that ends this slide. So thank you very much for viewing this video.